Okay, welcome to another GRE quantitative reasoning class. Yeah, so today we are still going to continue to discuss about the first aspect of the GRE quantitative reasoning, which is arithmetic. And in the last class, we concluded the first topic on arithmetic, that is number properties. And today we are moving on to the next topic, which is sequence. And under sequence, we'll be talking about the meaning of sequence. We'll look at sequence with a common difference, sequence with a common ratio. We'll look at defined sequence and also sum of sequence. All right, so if you're ready, I'm also ready here, so you can get your writing parts and let's move on to the main class. Okay, what is a sequence? A sequence is a set of numbers in a regular pattern. Yes, a set of numbers in a regular pattern. So the pattern can be of any form. Could be just adding a particular number, maybe subtracting a particular number, maybe multiplying by a particular number, or maybe dividing by a particular number, or maybe multiplying and dividing, or whatever. So we can have any kind of pattern. So as long as the set of values or the numbers can form a regular pattern, then we have what we call a sequence. Okay, now examples of sequence. We have 2, 5, 8, 11, 14, 17, and so on. Now, what do you think is the pattern in this sequence? Simple. We are simply adding 3 to the preceding term to get the next term. That is the pattern in the sequence. So, plus 3, we have 5. 5 plus 3, we have 8. 8 plus 3, we have 11. 11 plus 3, we have 14. 14 plus 3, we have 17, and so on. So this kind of sequence is said to have what we call a common difference. So the common difference is what we are adding or subtracting to produce the terms, and in this case, that is 3. Another example is this, which is 2, 4, 8, 16, 32, 64, and so on. Now, what do you think is the pattern in this sequence? Very simple. We are multiplying the preceding term by 2 to get the next. So, this 2 times 2, we have 4. The 4 times 2, we have 8. The 8 times 2, we have 16. The 16 times 2, we have 32. The 32 times 2, we have 64. So you can then tell me the next, which is times 2, that's 128, and so on. So obviously here we are multiplying by 2 to get the terms. That is the pattern. So this kind of sequence is said to have common ratio or a common ratio. So because we are multiplying by a value to produce the next term, so the common ratio will be 2. This is another example. 1, 2, 4, 7, 1, 2, 4, 7, 1, 2, 4, 7, and so on. What can you say about the pattern in this sequence? Yeah, very clear. We are not adding or subtracting or multiplying or dividing by anything. We simply have a set of 4 numbers that are being repeated indefinitely. Alright? A set of 4 numbers repeated indefinitely. So we have 1, 2, 4, 7, 1, 2, 4, 7, 1, 2, 4, 7. That is simply the pattern. So that's another pattern you can see. So this kind of sequence has no common difference or ratio. Yeah, no common difference or common ratio, because we are not adding or multiplying by anything. We are not subtracting or dividing by anything. So no common difference, no common ratio. Okay, so these are just some examples of what we call a sequence. Alright, now we have sequence with a common difference. Just like we said in the first example. Now, a sequence with a common difference is the one in which the terms are produced by adding or subtracting a constant value to or from the preceding term. Okay, so produce the terms here by simply adding or subtracting a constant value to or from the preceding term. So for instance, we have this example 1, 3, 6, 9, 12, 15, and so on. So from here, what's the pattern? We are simply adding 3. So plus 3, we have 6. Plus 3, we have 9. Plus 3, we have 12. Plus 3, we have 15, and so on like that. So, because we are adding a particular number to the terms to get the next, then this sequence has a common difference. So 3 is added to the preceding term to produce the next, hence the common difference will be 3. So our common difference is the value you are adding to get the terms. Another example is this: 12, 7, 2, minus 3, minus 8, minus 13, and so on. Now, what is the pattern here? Simple. We are subtracting 5 from the preceding term to get the next. So 12 minus 5 is 7. 7 minus 5 is 2. 2 minus 5 minus 3. Minus 3 minus 5 minus 8. Minus 8 minus 5 minus 13, and so on. So 5 is subtracted from the preceding term to produce the next. Hence, our common difference will be minus 5. So when you are adding to produce the term, the common difference will be positive. If you are subtracting to produce the terms, the common difference will be negative. Just take note of that. Or another way you can simply find the common difference is subtract the first term from the second, or the second one from the third, or the third from the fourth, and so on. So if I do 6 minus 3 gives me 3, or 9 minus 6, that's 3, or 12 minus 9, that's 3, or 15 minus 12, that's 3. Or if I come here, 7 minus 12, that is minus 5. Alright, so don't do 12 minus 7, otherwise you get a wrong common difference. 7 minus 12, minus 5, or 2 minus 7, minus 5, or minus 3 minus 2, minus 5, and so on. So to get your common difference, you can simply do that in order to get your common difference. Okay, so if you follow this and you are getting different answers, that means the sequence doesn't have a common difference. Alright? Okay, now we have what we call nth term. What do you mean by nth term? The nth term of a sequence with a common difference is given as this. So that is when you say nth term, you're talking about a particular term of the sequence. A particular term of the sequence. It could be the third, or the fourth, or the fifth, or the 70th, or the 85th term, anyone. That's what I mean by nth term. So this relation or the formula here, we can use it to calculate any particular member of a sequence that has a common difference. Okay, once the sequence has a common difference, you can use this formula to calculate any member of the sequence. Tn is equal to a plus open bracket n minus 1 bracket closed times d. So the Tn is the term we want to find. Alright, A represents the first term of the sequence. The first term of the sequence. D represents the common difference. Your common difference. And N represents the position of the term to be found. So meaning if you are finding the 20th term, our N will be 20. If you're calculating the 17th term, our N will be 17. If you are finding the 91st term, our N will be 91. Alright? So that is how we calculate any member of the sequence without stressing ourselves. So let's look at some simple examples here. Example 1 says minus 5, minus 2, 1, 4, 7, 10, and 13, and so on. Now, what is the 50th term of the sequence above? What is the 50th term of the sequence above? So, okay, now let's see how we answer this question using the formula of the nth term. Okay, so now the question is asking us to find the 50th term of this sequence. Minus 5, minus 2, 1, 4, 7, 10, 13, and so on. Now, to find any member of the sequence, remember, we check. Let's see if it has a common difference so that we can apply our formula. And if you check, check the pattern and see what we do to the terms to produce the next. And of course, from -5 to -2 simply means we are adding 3. Plus 3 we have -2, plus 3 we have 1, plus 3 we have 4, plus 3 we have 7, plus 3 we have 10, and so on. Or again, you can decide to use the formula. So our common difference will be equal to the second term minus the first, which is going to be -2 plus 5, and that is 3. Or the third term minus the second, that is 1 plus 2, same as 3. Or the fourth term minus third, which gives us 3. So it shows you are getting the same thing. Therefore, this is our common difference. So remember, since that's a common difference, then the formula to calculate the nth term of any of the sequence will be Tn is equal to a plus n minus 1 bracket close d. Alright, so don't forget our a is our first term, and the first term here is -5. That's first term of the sequence. Our d is the common difference, which is what? 3. You can see that here. Okay. Now, what is our n? Our n is the position of the term we want to find. So since we want to find the 50th term, that means our n is 50. Okay, so you input all this in the formula. It means 50th term. Don't forget our n is now 50. So 50th term is equal to a, which is -5, plus open bracket n, which is 50, minus 1 bracket then d, which is our 3. Okay, so this gives us -5 plus 50 minus 1 will give us 49, then times 3. And what does that give us? We have -5, so plus, so if we multiply 49 times 3, this one, 49 times 3, that will give us 147. Alright, so this means -5 plus 147, which will give us 142. Forget that same thing as 147 minus 5. Right? Same thing. Okay, so it means our 50th term is 142. Okay, so that is how we can find any member of the sequence. So that means if we keep writing this sequence, first term, second term, third term, fourth, fifth, sixth, seventh, till we get to the 50th, we get 142 as our 50th term. Alright, so that is how we find the member of any sequence. Once you know the formula for the nth term, we want to start common difference like this, can apply the formula and then we get any member of that sequence. Alright, so now example 2, it says find the 96th term of the sequence 35, 31, 27, 23, and 19, and so on. Okay, so here we are finding the 96th term of this sequence. Alright, so just let's see if that's a common difference so that we can apply our formula. Alright, now from the sequence we have here, it is obvious that this has a common difference, and of course the common difference, that's our d, is 31 minus 35, or same as 27 minus 31, or same as 23 minus 27, and this gives us -4. Alright, So that is our common difference. So our common difference is minus 4. Okay, now what is our first term? Of course, first term A, that is 35. As you can see from the sequence, 35. That's our first term. Right? Then we are finding the 96th term. So our n, 96th term. So that will be 96. So now recall that our nth term is a plus n minus 1 bracket d. Therefore, our 96th term will be equal to a, which is our 35, plus n, which is 96, minus 1 bracket d, which is minus 4. Okay, so this gives us 35 plus 95 bracket minus 4, and this will give us 35 plus, so we multiply 95 by minus 4, we get minus 380. So this means we have 34 minus 380, and therefore we will have minus 345. Okay, so this means our 96th term will be equal to minus 345. So that is exactly what this means. Okay, so if we keep writing, we'll get minus 345 as our 96th term. Alright, so that is the solution to our second example under sequence with a common difference. Okay, now we have sequence with a common ratio. Alright, so a sequence with a common ratio is the one in which the terms are produced by multiplying or dividing the preceding term by a constant value. Okay, so if we produce our terms by simply multiplying or dividing by a constant value, we have a sequence with a common ratio. So for example, here we have 2, 8, 32, 128, and so on. And when you check this, what are we having here? We are multiplying the preceding term by 4 to get the next. So 2 times 4 is 8, 8 times 4, 32, 32 times 4, 128, and so on like that. So the preceding term is multiplied by 4 to produce the next term. Hence, the common ratio will be 4. Alright, common ratio will be 4. So to get our common ratio, we can divide the second term by the first. That's 8 divided by 2 to give us 4. Or the third term by the second, which is 30 divided by 8. Or 120 divided by 32, which is the fourth divided by the third. Alright, so in the second example, we have 9, 3, 1, 1 over 3, 1 over 9, and so on. And if we check this, what are we doing? We are simply dividing the first by, or the preceding term by 3 to get the next. So if you divide 9 by 3, you get 3. Divide 3 by 3, you get 1. Divide 1 by 3, you have 1 over 3. Divide 1 over 3 by 3, you have 1 over 9, and so on like that. So in this case, our common ratio will be 3 divided by 9, or 1 divided by 3, or 1 over 3 divided by 1, and so on. And that will be giving us 1 over 3. So when we are multiplying, our common ratio is the number we are multiplying with. But when we are dividing, our common ratio is 1 over what we are dividing with. Alright, so that is what we mean by common ratio. Now you get the common ratio. So you can find the common ratio by dividing the second term by the first, or the third by the second, or the fourth by the third, and so on like that. Now we have the nth term as well. So to find nth term, that is any member of a sequence with a common ratio, you can simply use this formula. Tn is equal to AR raised by n minus 1. Alright, so the A is the first term of the sequence. The R is the common ratio of the sequence. The N is the position of the term to be found. So if we want to find our 50th term, our N will be 50, and so on like that. So we use this simple formula to calculate any member of a sequence with a common ratio. All right. Now let's see these two examples quickly on how we can find a member of a sequence with a common ratio. So example 1 says we have 3, 6, 12, 24, 48, 96, and so on. Now it says find the 20th term of this sequence above. The 20th term of the sequence above. So now we check if you have a common ratio, and if we have, then we can simply apply the formula. All right. So okay, so now this sequence here, as you can see, that's a common ratio because that means we multiply 3 by 2 to get 6, multiply 6 by 2 to get 12, multiply 12 by 2 to get 24, plus 24 by 2 to get 48. So therefore our common ratio, right, common ratio will be our R, that is 2. So like I said again, you can decide to divide 6 by 3 or 12 by 6 or 24 by 12 to get our common ratio. Okay, then the first term of the sequence, that's our A, is 3. So you can see here we have 3, and because it's asking us to find the 20th term, so that means our N is 20. So since our sequence has a common ratio, then we can use the formula to calculate the nth term of a sequence with a common ratio, which is AR raised to power n minus 1. So this means our 20th term will be equal to A, which is 3, times our R, which is 2, raised to power n, which is 20, minus 1. And this gives us 3 times 2 raised to power 19. Okay, so in a typical GRE question, they will not expect you to simplify this 2 raised to power 19, that is, make it like a single whole number. So because they know that it's probably going to take a long time to get this with the calculator, so rather they will just leave your options in this form, in exponent form like this. So you don't need to bother yourself trying to multiply or get 2 raised to power 19 like 2 times 2 times 2 times 2 19 times to see what the answer will be. No, they will leave your options in this exponent form, So you don't need to bother yourself. So the 20th term here will be equal to 3 brackets 2 raised to power 19. Okay, or we can write it as 2 raised to power 19 bracket 3. Anyhow, still the same thing. All right, so we can always get that in that form. Now, another short method we can apply when it comes to a sequence with a common ratio is that we can actually study the pattern of the terms, all right, the pattern the terms are forming, and use these patterns to get anyone they're asking us to find. So that means even if in case you forget the formula, you might still be able to do this and get the right answer. For example, 3 can be written as 1 times 3, which I can write as 2 raised to power 0 times 3, because 2 raised to power 0 is 1. Now 6 can be written as 2 times 3, that is 2 raised to power 1 times 3. 12 can be written as 4 times 3, which is 2 raised to power 2 times 3. 24 can be written as 8 times 3, which is 2 raised to power 3 times 3. So what can you notice in this pattern that we are seeing here? Now our first term is giving us 2 raised to power 0 times 3. Our second term is giving us 2 raised to power 1 times 3. Third term giving us 2 raised to power 2 times 3. Fourth term giving us 2 raised to power 3 times 3. It simply means the position of the term, just subtract 1 from it, that will be the power of 2, and then times 3. So if I'm finding my 20th term, so what does that mean? I will subtract 1 from 20, that will be the power of my 2, so that will be 2 raised to power 19 times 3. Okay, so which is same as our answer here. Alright, so if I want to find the 60th term, that will be what? 60 minus 1. That will be 2 raised to the power 59 times 3 as our 60th term. 75th term, okay, will be 75 minus 1, which will be 2 raised to the power 74 times 3. So, from the pattern here, I can simply get any member of the terms, even if I forget the formula or I don't want to use the formula. So, this is one good advantage you will see when we have a sequence with a common ratio. The members will form a pattern that you can even use to get any other member of the sequence. Alright, so let's look at the second example. So the second example says, what is the 50th term of the sequence 9, 3, 1, 1 over 3, 1 over 9, and so on? Alright, so what's the 50th term of this sequence? Okay, so now we have 9, 3, 1, 1 over 3, 1 over 9, and so on. And we have to find the 50th term. So now you can decide to pause the video, try to solve the question by yourself using the formula method and also using the pattern method that we discussed the other time. Okay, so now let's quickly run through the solution. So if you are done with your solution, and then check if you are right or wrong. Okay, so here from this sequence, you can see that there is a common ratio definitely, because it means you divide 9 by 3 to get 3, divide 3 by 3 to get 1, divide 1 by 3 to get 1 over 3, and so on. So it means you are dividing by 3 to get the next term. Therefore, our common ratio R will be 1 over 3. Okay, remember when you divide by 3 or divide by a number, the common ratio will be 1 over the number you are dividing with. Alright, then our first term A will be 9. Okay, that's our first term A. Then we are finding the 50th term, so that means our N will be 50. Therefore, using our formula, Tn is AR raised to the power n minus 1. So this means our 50th term, T50, will be equal to A, which is 9, times R, which is 1 over 3, okay, raised to the power of 50, that's our n minus 1. So here, we will need to do a little mathematics here, seeing an exponent here. So our 9 can be written as 3 raised to the power 2. Why did I do that? Because I can see 3 here. So I can write this as 3 raised to the power something as well. So I'll use my exponent idea. So times, now this 1 over 3 is something as 3 raised to the power 1. Alright, you understand that better when we get to exponent. Okay, so 3 raised to the power 1 and 50 minus 1 will give us 49. So which means I can now have 3 raised to the power 2 times, this will be minus 1 times 49. We multiply these two to give us 3 raised to the power minus 49. And for my rules of exponents or indices, this means 3 raised to the power 2 plus minus 49. Okay, and that will give us 3 raised to the power 2 minus 49, which will be 3 raised to the power minus 47. Alright, so or which you can write as 1 over 3 raised to the power 47 as our 50th term. Okay, 3 raised to the power minus 47 or 1 over 3 raised to the power 47. That will be our 50th term using the formula. Okay, now if you want to use the pattern method, let's see. Now 9, which is 3 raised to the power 2, we have 3, which is 3 raised to the power 1, we have 1, which is 3 raised to the power 0, we have 1 over 3, which is 3 raised to the power minus 1, we have 1 over 9, which is written as 1 over 3 squared, and this is written as 3 raised to the power minus 2. So from this pattern here that we have, alright, if I write it out, I have 3 raised to the power 2, 3 raised to the power 1, 3 raised to the power 0, 3 raised to the power minus 1, 3 raised to the power minus 2, and so on. So the powers, they're actually giving me consecutive integers. Remember that? Consecutive integers 2, 1, 0, minus 1, minus 2, and so on. So if I want to get the 50th one, this is the first, the second, the third, the fourth, the fifth. I want to get the 50th. So what do I do here? It's all about just looking at the power, because these are all just 3 raised to power 3 raised to power 3. So my 50th term will still be 3 raised to power, but power what? Now that means we are writing numbers from 2 downwards, and want to write 50 numbers consecutively downwards from 2. So 2, 1 already out of 50 numbers, remaining 48 numbers. 48 numbers that will start from 0. So I'm going to write 48 numbers consecutively from 0. What does that mean? It means 0 minus 1 minus 2. So it means my last number must be minus 47. Alright, because if I start from minus 1, it will be to minus 48. Alright, so if I'm starting from 0, it will be to minus 47. So that means my 50th term will be 3 raised to power minus 47, or 1 over 3 raised to power 47 as the 50th term. So if you use the formula, we get this answer. If you use the pattern, we can still also get our answer for a sequence with a common ratio. Okay, so that's how you can find any member of the sequence with a common ratio. All right, so that's the solution to our example 2, how you can get the 50th term of this sequence. Okay, now we have what we call the find sequence. Now here it's simple thing. Actually, this is actually the common ones we see in the GRE exam. So instead of listing the members of the sequence like the examples we just did, they rather give you the definition of the sequence. So what I expected to do is to use the definition to get some terms of the sequence. So you can ask you to get any term, any member of the sequence or whatever. Okay, so for example here, this is a definition. Number 1, Sn is equal to Sn minus 1 plus 2. Okay, Sn is equal to Sn minus 1 plus 2. So it says from the definition above, Sn minus Sn minus 1 is equal to 2. Means this 2 because you give us a common difference D. What are we saying here? It's because these two terms, if you look at it, they are consecutive. Like your T2 and T1. Like for instance, if your N is 2, this will be S2, this will be S1, and you will get 2. If your S is 3, this will be S3, this will be S2, 2 consecutive terms, and you still get 2. If your S is 4, this is your S4, this is your S3. So that means we get 2 again as our common difference. So since we are getting the same number by doing T2 S2 minus S1, or S3 minus S2, or S4 minus S3, and we're getting 2, then automatically this 2 is a common difference. So if it's a common difference, then we can use the definition or the formula to answer any problem given to us using this kind of definition. Alright, so for instance, let's say we have this definition as a question. Alright, as a question. For instance, let's say we have something like this. Sn is equal to Sn minus 1 plus 2 for all n is greater than or equals to 2. Now, if S1 is equal to 6, find S3. Okay, so we have just given the definition of the sequence. And just like what we just explained, from this, we have Sn minus Sn minus 1 to be equal to 2. So this 2 is a common difference. Common difference. That's our D. Alright. So now, this, since I've been able to confirm that this definition or this sequence has a common difference, then I have 2 ways to answer my question. I can decide to use the definition given to me to solve the problem, and I can also decide to use the formula. That's Tn is equal to A plus n minus 1 bracket D. Since that's a common difference, so that's no problem. So I can use the formula, I can use the definition. Now, let's use the 2 and see the difference. So if you're using the definition, now that means I will start using I will use the definition to start finding the members from the first term, which has been given already, our S1, to anywhere I'm going, maybe S3 or S4 or S5 or S6. I'll be doing it one by one. So now they've told me my S1 is 6, and that is my first term. When you say 1, that's first term. So that's my A. Okay, so now we have the common difference already. Now we don't need all this when we are using definition anyways. So we only need A and D when we are using formula. But now if I want to use definition, I will just go straight to my definition. So my Sn is equal to Sn minus 1 plus 2. So they have told me that my n starts from 2. That's from 2 and above, greater than or equals to 2. So if n is equal to 2, then that means I have S2, that's 2 will replace n, is equal to S, that will be 2 minus 1, which will be 1, plus 2. Now recall, my S1 is 6. Therefore, we have 6 plus 2, which is equal to 8. So that's our S2. Now, if n is equal to 3, then we are going to have S3, that's 3 replacing n, is equal to S3 minus 1, which will give me 2 plus 2. So now my S2 is 8. That means I'm going to have 8 plus 2 is equal to 10. So that is my answer, the S3 the question is asking me to find. Okay, so if it says 4, they're asking me, that's how I'll continue till I get to S4. If they're asking me S7, that's how I'll continue till I get to S7. So, but the point is, from the pattern you are seeing, you can actually try to see the shortest way to go about it. And most times, they don't really ask something too far, like maybe S10 or S whatever, except if there is going to be a simple pattern you can follow to get the answer very fast. Okay, and otherwise, you can also use our formula here, as you can see, is our formula, and for the formula, our A, like you can see here, it's already 6, that's our first term. Our common difference D is what? Is 2. Is 2. So now we can simply put all this in this formula. Now, what is our N? They're asking us to find S3. That means the third term, so our N will be 3. So put in the formula, that means we're going to have T3, which is the same thing as our S3, is equal to A, which is 6, plus N, which is 3, minus 1, bracket, common difference, which is our 2. Okay, so this gives us 6 plus 2 bracket 2. And that will be 6 plus 2 times 2, which will give us 4. And that is equal to 10. So same as this. So we can find our S3 by using the formula or using the definition, since it has a common difference. So in case the formula does not, or the definition does not have a common difference, that means you cannot use the formula. So you have to use the definition itself, alright, to solve the problem. So that's one thing you have to understand there. Alright, so this is an example. So Qn plus 1 is equal to Qn over 3. And if you look at this, if I bring Qn under Qn plus 1, then I'm going to have Qn plus 1 over Qn to be equal to 1 over 3. So, for instance, my n is 1, I have Q2 over Q1. Just like you have T2 over T1. If your n is 2, you have Q3 over Q2. If your n is 3, you have Q4 over Q3. So, they are consecutive terms. Therefore, this 1 over 3 stands as our common ratio. So, if I have a question or something like this as well, I can use the definition. I can also use the formula. The definition or the formula. So, like I said, there are some definitions that cannot produce a common ratio or produce a common difference. So, in those kind of definitions, you don't have a choice. You just have to use the definition. There's no way you can use a formula, because once there's no common ratio or common difference, you can't use any of those formulas. You must use the definition. So, for instance, you can have a definition like this. Maybe Sn is equal to 2Sn minus 1 plus 5. Okay, so in this kind of definition, if I do what I did the other way, and the other one where I brought this to this side, and if I do that, I'm going to have something like this. Okay, now as it is, this 5 is not a common difference, because this Sn and 2Sn are not consecutive. They are not consecutive. Why? Because of these two. If you have this, yes, they are n minus 1. If you have something like this, yes, they are n plus 1 n. Alright, those are consecutive terms. Or maybe you have something like this, n plus 2, n plus 1. Alright, so they are consecutive terms. But once you have any number, they are not going to be consecutive. So that means this definition will not produce a common difference and will not produce a common ratio. Therefore, if we must answer any question on this, we must use the definition itself. Alright, so that is exactly what we are trying to say in that aspect. Okay, now let's look at these two past exam questions. Alright, number one says the nth term of a sequence is given by un is equal to 2 plus 3 un minus 1, while u4 is equal to 36 plus u3. Find the third term of the sequence. Find the third term of the sequence. Okay, now looking at this question, you will see, just like I explained the other time, that this cannot give us a common difference or common ratio because there's a number at the back of this. So now in that case, we have to use the definition of the sequence itself. And now, of course, this is a GRE question. Don't expect all questions to be the same way. Of course, you have to put in your reasoning here. Now, there is a general definition. Un is equal to 2 plus 3 un minus 1. And now, there is another thing given to us here, which is u4 is equal to 36 plus u3. And they're asking us to find that u3, the third term of the sequence. So, in that case, what I would do, since I'm seeing u4, I will try to produce u4 from the definition here. From the definition, that means my n will be 4. So, if my n is 4, I'm going to have u4 is equal to 2 plus 3 u. So, that will be 4 minus 1, which will give me 3. So, this means my u4 is 2 plus 3 u3. And the same u4, according to the question, is equal to 36 plus u3. Okay, therefore, these two are the same since they are both equal to u4. So then I can say 2 plus 3 u3 is equal to 36 plus u3. Alright, so what do you need to do? We are just going to collect like terms. All the u3, let them be on the left hand side. Okay, and the numbers, let them be on the right hand side. So I'm going to have 3u3. So I'll bring this one to the other side. It becomes minus u3 is equal to, I have 36. Then 2 will come to this side. It becomes minus 2. So 3 minus 1 u3. That will give me 2u3 is equal to 36 minus 2, which will give me 34. So therefore, my u3 will be 34 divided by 2. So meaning u3 will be 17. Okay, so that is the answer to this one. So it is not like the other one we just need to find u1, u2 to get to u3. No, they have already given us something that can make the work faster. So you can simply follow that clue. It's just like a clue for us. And follow that to get our answer quickly. So this will be u3 is equal to 17, the third term of the sequence. So that's solution to that example 1. Okay. Example 2. In a sequence, Rn plus 1 is equal to 1 over 3 Rn. And R1 is equal to 6. Quantity A, R11. Quantity B, 3 raised to the power 17 R28. Okay, so now let's see the solution to this question. You may pause the video and try to solve this by yourself. Find your R11, find your R28 and multiply by 3 raised to the power 17 and see which one is bigger, or maybe they are equal. Alright, so now let's see what the solution will look like. Okay, Okay, so now from this definition, 1 over 3 Rn, as you can see, I can decide to say Rn plus 1 over Rn is 1 over 3. And from here, since I know that these two are consecutive terms, definitely this 1 over 3 is a common ratio, because it's just like if my n is 1, it will be R2 over R1, or if my n is 2, that will be R3 over R2. My n is 3, that will be R4 over R3. So since it gives me a number, that means that is a common ratio. So it shows this sequence has a common ratio. In that case, since I'm saying R11, R28, to make my work easier, I will just go straight to my formula, straight. Alright? And remember the formula, our Tn, or let me use R now, will be equal to AR raised to power n minus 1. So the R is the common ratio, and our A is the first term, which has been given in the question as our R1, which is going to be 6. Therefore, first, what is my R11? My R11 means my n is 11. And that means my R11 will be A, which is 6, times R, which is 1 over 3, raised to power n, which is 11 minus 1. And this will give me 6 times 1 over 3 raised to power 10. Okay, I will leave it like that. Alright, now let's go to my quantity B, which says 3 raised to power 17 R28. This means 3 raised to power 17 times R28. So, well, I just need to know my R28. 3 raised to power 17 is just a number. So 3 raised to power 17 times, now my R28 using the definition or the formula will be the first term, which is A, and that is what's our A? 6. Okay, that is 6 times our R, which is what? 1 over 3 raised to power n, which is what? 28, the number of term, minus 1, and that gives us 1 here. So this becomes 3 raised to power 17 times 6 times 1 over 3 raised to power 28 minus 1 will give us 27. Now, since I'm seeing this, I will need to simplify this. So here, let me take the 6 first, then times 3 raised to power 17. So just like I said the other time, times this one here is something as 3 raised to power minus 27. Okay, so this gives 6 times 3 raised to power 17 plus minus 27, and that will be 6 times 3 raised to power 17 minus 27, which will be 6 times 3 raised to power minus 10, which is the same as 6 times 1 over 3 raised to power 10. Wow. So that means our R11 is actually the same, as you can see, as our 3 raised to power 17 R28. So what does that tell us? That means the two quantities are equal. So our answer will be C, equal. Okay, so that is a good example for us to look at a sequence in common ratio, even when you are given in terms of definition. Alright, like I said, it's a GRE real exam past question. We have sum of sequence, okay, which is not really too common, but you can come across it once in a while. So it simply means some members of a sequence. So if you need to add some members of a sequence, you can, that's what I mean by sum of sequence. You can ask you to find the sum of the first 10 terms, some of the first 20 terms, some of the first 50 terms, some of the first 100 terms, anyhow. So that's what I mean by sum of a sequence. Alright, so now if our sequence has a common difference, we can find the sum of a set of members of the sequence by using this formula here. That is if it has a common difference. That's all. If it has a common difference, we can use this formula. Then sum will be A plus L over 2 all bracket close times n. So your A is the first term or the first member of the group to be summed. Okay, so if you want to find the sum of the first 20, that means A will be our first term in the sequence. Now, the last term is what the L represents, the last member of the group to be summed. So if you are finding the sum of the first 20 terms, then the last term must be the 20th term. While the first term will be our A. Now, n represents the number of terms to be summed. So if you are finding the sum of the first 20 terms, that means n will be 20. Alright, so to find the sum of any sequence with a common difference, you can use this A plus L over 2 bracket n. Like I said, A means the first, L is the last of the members to be summed, and 2 is the number of terms to be summed. So if you are summing the first 50, A will be the first term of the sequence, L will be the 50th term of the sequence, and n will be 50. Okay, so that's how you can find the sum of sequence with a common difference. Now, others kind of sequence you can find their sums too, but most times when they give us that kind of a question in GRE, they ensure that they give us a sequence that has a pattern. So you simply use a pattern to find the sum. Yes, we use a pattern to find the sum. Alright, so let's look at these few examples on sum of sequence to wrap up the topic. Okay, so now we have first question says, what is the sum of the first 20 terms of the sequence 4, 10, 16, 22, 28, and so on like that. So what's some of the first 20 terms? Some of the first 20 terms. Alright, so now let's see how we solve this question. So from this sequence, as you can see, we have 4, 10, 16, 22, 28, and so on. So it is obvious that the sequence has a common difference. That is, you add 4 to get 10, plus 4, 16, plus 4, 22, plus 4, 28, and so on. So it means our common difference, that's our D, is 6. Because that's the number we're adding to get the terms, plus 6, plus 6, plus 6. Alright, and our first term, A, is 4. Okay, so because that's going to find the sum of the first 20 terms. Sum of the first 20 terms. And don't forget, the formula will be A, which will be the first of the terms to be summed, plus L, which will be the last of the sum of the terms to be summed, over 2, then bracket n, which is the number of terms to be summed. So therefore it's clear that our A is the first term, and which we know now to be 4. Our L must be the 20th term. 20th term, because we are finding some of the first 20 terms. So the 20th term, and we don't know it now. So which means we need to find that first by using our formula for the nth term. Tn is equal to A plus n minus 1 bracket D. So if we are finding our 20th term, that means we have A, which is 4, plus n, that means that's 20. Position of the term we want to find 20 minus 1 times common difference, which is 6. And this gives us 4 plus 19 times 6. Alright, so now what do we have here? That means we will have our 20th term to be equal to 4. Alright, so 4 plus 19 times 6. And 19 times 6 will give us what? That will give us 114. Okay, so 4 plus 114 gives us 118 as our 20th term. So therefore, now the sum that we are looking for will be A, which is our 4, plus the last term, which is our 20th term, and which is 118, divided by 2 times n, which is the number of terms we are summing, that is 20. Alright, so if if we add this 118 plus 4, will give us 122 divided by 2 times 20. So I could do it like this: 2 here, 1 here, 10, and that means we have 122 times 10, and which will give me 1220 as the sum of the first 20 terms of this sequence. Right? So that is how we can find the sum of a set of members of a sequence with a common difference. Okay, so the second example says, find the sum of the first 99 terms of the sequence 145, 145, 145, 145, and so on. So the first 99 terms of the sequence. Okay, so you may pause the video, try to look at the question and see if you can answer the question. Alright, so let's see what the sum of the first 99 terms of this sequence will be. Okay, so the question is asking us sum of the first 99 terms of this sequence. And as you can see in this sequence, there is no common difference. So we cannot use that formula for sum. No common difference. Because here we have 4 minus 1, which will give me 3. 5 minus 4, which will give me 1. So no common difference. And what we simply have here is just a repetition of these three numbers: 145, 145, 145, 145, 145. So what can we do here? We just have to use our reasoning here. Reasoning, simple reasoning. There's no formula to use. Now, what reasoning can we apply? What I will just try to do is this 145, I will try to get the sum of this 145. And I will try to see how many of this 145 I can get in 99 terms. Alright? How many of this 145 will I get in 99 terms? And now, 145, I have 3 numbers. So all I need to do is to divide 99 by 3. Simple. Divide 99 by 3. So if I divide my 99 by 3, I get 33. So it means this 145, like this, will appear 33 times, like that, 33 times in the whole sequence, 33 times. So now that means the sum of the first 99 terms will be equal to what? This 145 added together, how many times? 33 times. 33 times. So which gives me 10 times 33. And that means I'm going to have 330 as the sum of the first 99 terms of the sequence. Alright, so that is a strategy we can apply here to solve this kind of question. So just get the group, what's sum of the group, and how many of those groups can you get? Okay, now let's say the question says you should find sum of the first 101 terms. Sum of the first 101 terms. I just want to show something here. Now, if I do the same steps, that means 101 divided by 3, because I have 3 numbers repeating. If I have 4 numbers repeating, I will divide by 4. If I have 5 numbers repeating, I will divide by 5. So what does this give me? This gives me 33 remainder 2. Okay, so how do we do the sum here? Now, it means that this 145 will repeat 33 times completely. Then after the 33rd time, then we have 1 and then 4. So that means the first 2, that's what these 2 represent. That means now we have 145 repeating 33 times, and that will be equal to 1 plus 4 plus 5, 33 times. Okay, now plus the first 2 numbers, 1 plus 4. So this gives me 10 brackets 33 plus 5, and that is 330 plus 5, and that will give me 335 as sum of the first 101 terms. Okay, so that is how we can solve that question. Alright, let's look at the last one. It says a sequence C is defined as Cn is equal to 1 over n minus 1 over n for all n is greater than or equals to 2. So what is the sum of the first 100 terms of sequence C? Sum of the first 100 terms of sequence C. So here we are given the definition of the sequence, which means we would need to definitely use the definition to get some of the members of the sequence. Then we can check the pattern to see if we can get the sum of the first 100 of the sequence. So let's see how we can solve this question. Okay, so from here we have Cn to be equal to 1 over n minus 1 minus 1 over n. Now our n starts from 2, so we just need to try start from 2 and see maybe we can get the first 3 or first 4 terms and check the pattern to see how I can use that to get the sum of the first 100. So when my n is 2, then I have C2 to be equal to 1 over 2 minus 1 minus over 2, and this will be 1 over 1 minus 1 over 2. This is going to give us 1 minus half. Alright, so if n is 3, let me just do this quickly. This will be C3 is equal to 1 over, that will be 3 minus 1, which will be 2 minus 1 over 3. When our n is 4, then we have C4 to be 1 over what? 4 minus 1, which will be 3 minus 1 over 4. So if you look at this sequence we have here, we have 1 minus 1 over 2, 1 over 2 minus 1 over 3, 1 over 3 minus 1 over 4. We can only use this pattern to get the sum. No way, you can't use this pattern to get the sum. It's not really giving us a pattern that we can use to get the sum easily. Now, if that is not working, the another thing we now do is to get this pattern of the sum. And that is just do like the sum of the first two, sum of first 2 terms. Okay, and that will be 1 minus 1 over 2 plus 1 over 2 minus 1 over 3. That's the first and second. And this eliminate this, and this gives us 1 minus 1 over 3. If I do sum of the first 3 terms, this will be equal to, now this is sum of the first 2, which is 1 minus 1 over 3, so plus the third term, which is 1 over 3 minus 1 over 4. And this eliminates this, and that gives me 1 minus 1 over 4. So if you look at this and this, they have a pattern. That is 1 minus 1 over 3, 1 minus 1 over 4. So some of the first 2, 1 minus 1 over 3. Right? Some of the first 3, 1 minus 1 over 4. So what do you think sum of the first 100 terms? That will be 1 minus 1 over 101. Because when you have 2 terms, you have 3 here. When you have 3 terms, you have 4. So if you have 100 terms, you have 101. And that will be, if you take LCM, you have 101. That will be 101 minus 1. And that will be 100 over 101. So that will be the sum of the first 100 terms of this sequence. Okay, so that is the end of the class. I want to believe you've learned so much about sequence in this class today, and that's all you need to know about sequence. You've just been able to run through the second topic in one class. So advice that we'll go through the videos again and the questions, and then practice the questions by yourself and look for more questions to practice. And so that is the end of the class, and we definitely continue with the next topic from the next class. So see you then. Bye.